Hello, my name is Dr. Michelle EICHINGER, and I'm very happy to be able to present to you this morning. I'm going to be presenting on the spatial analysis of community nutrition and the local food environment. Before I go into details of the presentation, I do want to take a little bit of time to review the agenda for my presentation. First, I will review some objectives of the presentation. I will then provide a background of GIS in analyses, and then I will detail some applications of GIS in community nutrition and local food environment with specific examples from the UrbanFOSC project. Lastly, I will describe some implications of spatial analysis. In the objectives, in this presentation, I'm going to present some findings from the UrbanFOSC research project, which is a project that we are collaborating with our partners in Algeria, Kenya, and South Africa, and it focuses on the urban food resilience under climate challenges. In this presentation, I will review some GIS, terms. So we hope to understand the use of GIS in analyzing and addressing community problems. Also, during this presentation, you will identify examples of GIS applications in analyzing community nutrition and assessing local food environments. And lastly, we will be able to recognize the implications of spatial analysis. So let's start with the background. Geographic information systems, also known as GIS, is not new in health-related studies. The study of using GIS really focuses on the term where, examines where are the resources, where are the incidents. So the focus of this research provides a dimension of where. In the field of using GIS, two most commonly used software is the Esri's ArcGIS software system and QGIS. Esri ArcGIS is costly. It does require a license, which can be purchased in a subscription, either individually or as an institution or with a business. Esri ArcGIS provides great analysis, cartography, and great editing, but the disadvantages is that it is costly. QGIS, however, is an open source and it's free to anyone who's interested in using it. It does provide great analysis tools. It allows for cartography and editing, but it does have limited web mapping capabilities, and it has limited availability of specialized tools. Now, I focus on ArcGIS mainly because my university, my institution, has a software license, and I've personally have been trained in ArcGIS, so I do prefer ArcGIS. However, QGIS is just as good, and it's also a lot more beneficial cost-wise. In order to do some mapping, it's important to know that there are certain formats that we require for data analysis and data for mapping. Those are GIS formats, including GPS coordinates. Sometimes you can just use an address, but the GIS formats usually come into shape files or .shp, KML files, or a geodatabase or .gdb. So let's talk about mapping the data. Usually the first step in GIS applications is mapping the data. This provides a descriptive review of the area using points, lines, and polygons, or what we call vector data. Raster data represents data as a cell or a grid matrix, and raster data consists of pixels, and each pixel has an associated value. This can display information that is continuous across an area. We can also aggregate data to get a summary of areas or within an area or within neighborhoods. So for an example, we can map all the producers in a region. We can ask the question, where are the farms? Next, we can map where we have households experiencing food insecurity. In this map, we also can identify the walking distance to the closest transit and ask the question, what is the catchment area for transits? Lastly, we can aggregate data to neighborhoods. In this map, we can compare diet diversity between wards of a city. In this map, we have raster data displaying all the types of land cover in a region. This is an example of all the types of land cover for the Breda Valley municipality in South Africa. There we see a lot of low shrubland in the olive green color. And we also see a lot of cultured commercial vines for table and wine grapes, which is represented in the burgundy color. And the residential and built area is concentrated in the bright yellow areas. So these are just examples of how data can be mapped. Here, we're going to talk about how we could use some certain tools in GIS applications. This is a common tool that I personally like to use to measure distance and real distance. So in the network analysis, which is a tool that can be found in both QGIS and Esri ArcGIS, we are looking at the nearest driving distance from home to a supermarket. So here, I'm using the network analysis tool to look at, hey, if I want to drive from my home to the supermarket, it looks at the road network and be able to decipher a specific route to get there, usually the nearest route. Now you can change this in the toolbox to look at walking distance or driving time. Either one of those you can specify. But in this case, I wanted to look at driving distance from the home to the closest supermarket. So we can use the data points to represent our house and data points to represent supermarkets. One of the advantages for network analysis is that it can determine alternate routes if you choose to. So for an example, if there's a road closure or there's other barriers, the network analysis tool can provide alternative routes should you include those particular barriers into the system. The reason why I like using the network analysis tool is that it provides a more realistic view of distance in terms of how we get from point A to point B. This differs from what we would call measuring the Euclidean distance. The Euclidean distance is just a term that we like to say, how does the bird fly, or where does the crows fly? Birds do not have barriers in getting from point A to point B. They can just fly there. In reality, for us humans, we have a road network that we follow, or we have other barriers, physical barriers. For example, we may be prohibited from getting from point A to point B because of a specific river. So a Euclidean distance would not provide a realistic way of measuring distance, but rather having a road network where it allows for distance to include a bridge that connects road systems to your desired location. So that's why I like using the network analysis tool. This is useful in planning. If you're in the planning field, it can definitely tell you how to get from point A to point B if there's a road closure. And if a resource B is closed, where is the nearest resource? So it's really great for planning purposes in that sense. In this example, again, I looked at the nearest distance from a household to the nearest supermarket, and I wanted to look at the distance, the driving distance, but I also wanted to look at walking time. So in here, I was able to measure both and was able to get a mean distance to the nearest supermarket being 1.5 kilometers, with a median distance to the nearest supermarket being just over 1 kilometer. When we factor in walking, the mean walking time to the nearest supermarket was about 18 minutes, and the median walk-in time to the nearest supermarket was close to 13 minutes. Here is an example of aggregating data and being able to compare neighborhoods. Here on the left, we see an aggregation of food insecurity and the different levels of food insecurity, from 0 being not as severe to 1 being very severe. So in this case, we're looking at, on the left, is the neighborhood level, and more specifically, neighborhood blocks of food insecurity and how that varies within a city. On the right, very similar, we're looking at the dimensions of poverty, being 0 being less poverty and 1 being the most impoverished. So we can overlap these particular maps to see where are our most vulnerable populations when it comes to poverty and food insecurity. So in mapping descriptive data, we have a couple of examples of how to demonstrate this. One example is interpolation. Interpolation is a tool that provides a continuous surface of information that provides the estimation based on an existing sample data of points. In this case, I'm looking at daily food expenses, and interpolation results in a raster format, as you can see with the different colors. In this example, again, I wanted to interpolate the daily food expenses for individual households, pretty much where are people spending the least amount of money and where they're spending the most. And so in this case, the dark red implies that people spend, or households are spending less than 93 Rand, or South African Rand. And in the green, they're spending between 960 to 1800 Rand for food purchases on a daily basis. I wanted to display this to determine, okay, so where are people spending their money, how much they're spending their money, and where are the closest supermarkets are, where the supermarkets are in relation to these food expenses. I've also mapped in here spazas. In South Africa, spazas are small, usually family-owned, entrepreneurial, informal stores. These are small retailers that tend to that are not regulated by the government. They are informal. They're pretty much operated by individuals and families. So I wanted to see where these were located and how that relates to where how much money is being spent on food. Now we're going to talk about spatial statistics. One of the most common forms of statistical analysis using GIS is the cluster analysis. Here we have an example of kernel density, and what kernel density maps show is it calculates the magnitude per unit area of a point and then a kernel function to smooth that area. So here's an example of the kernel density maps for racial demographics in this particular community in Worcester. As we can see, this is in South Africa again, and we're seeing still the legacy of post-apartheid, where the neighborhoods are highly segregated by race, where the green represents the Black Africans, the purple and pink area represents the colored Africans, and the blue area represents white Africans. And this is all in the city of Worcester, which is a small city north of Cape Town. I thought this was a very interesting map to really demonstrate because it really emphasizes visually the segregation that still exists in this community. Another popular tool for cluster analysis is what we call the hotspot analysis. Here I wanted to highlight hotspots of food insecurity. And so what this does in a hotspot analysis, it looks at local indicators for spatial autocorrelation. It measures the association between a value at a particular place and values of a nearby or adjacent areas. And so you would have to either use the default system in the tool, or you can specify that distance into the tool. This hotspot analysis then uses the tool calculating the GEDIS or GI star statistic to determine the hotspot analysis and significance. So here we have the dark red is the hotspot for food insecurity in the city of Worcester. And if you were to overlay this with our previous map, we see, for example, this, we see that our hotspots are highly concentrated in our colored African neighborhoods as well as our Black African neighborhood. Now let's look at modeling, and so looking at relationships. So the co-location analysis is a great tool if you want to be able to measure any kind of spatial association between two categories of points. This analysis uses the co-location quotient statistic. And here I wanted to look at the relationship. Is there a co-location between food insecure households and food insecure households? So, is it co-located? Is it more isolated? And we can also determine the significance of that. So in here, we see that in the dark green, that this is isolated, this is significant, where we are seeing high concentrations of food insecurity, and that is very isolated in those areas. In the white African, as you recall in the previous maps, the white African community, we see a co-located significance. So we see the combination of a combination of food insecure and food secure within the same area. Other common spatial relationship tools is we can look at regression analysis. So here I'm looking at using logit regression of food security status. So in the tool, you can input your explanatory variables. So in this case, I used household size, kitchen score, and daily food expenses. And then I also included spatial variables, including the supermarkets, the spazas, and the taxi stops, the minibus taxi stops. And the dependent variable in here is the food security status. In a logic regression, we have a binary value for this dependent variable. Food secured households are identified as 0. Food insecure households are identified as 1. And so using a logit regression tool into the system, we can identify spatially areas of food insecurity predictions. Now we're going to dive a little bit deeper into more of the food environment, namely agriculture. I like this map that one of my colleagues have produced for a project in Uganda. Here we're looking at food sheds. So the concept of a food shed is very similar to what we see as watersheds. And here we're looking at where households obtain their food supply. And so this is through household data and looking at retail data of where retailers obtain their food supply. And in Kampala, Uganda, we found that there is a regional local food production that contributes to a local share. And so the majority of the food that is supplied to consumers are actually locally produced and locally sourced. So this is especially true in the districts in and adjacent to Kampala, the capital city of Uganda. And so this actually represents where the food sourcing is coming from and where it's going. Now let's talk about some implications. So as I mentioned before, spatial analysis focuses on the where, in that it can inform decision makers beyond the typical descriptive data. And when we look at spatial analysis, it provides a great visual that tells a very compelling story. With that, we can look at beyond the people focus of interventions to look at more the place-based interventions and what I see as complementary. So it's best to look at both the people and the place to look at interventions. So in this example, I'm looking at the food system where people can include farmers and households and children and retail owners. And the place space will look at the markets, where these markets are located, and farms and other retail. So here is just an example looking at the supply and demand, people versus place. And this is just an example of some broad targeted policy and planning interventions and strategies. Another implication is in community development. I'm using an example here of early childhood development centers. So this would fall under the category of community development and social services. In our study, we did find that early childhood development centers provided a safety net in neighborhoods for emergency food. So if people, households, families found themselves in need of food, the early childhood development centers had a pantry or a food box program that would help feed families in the community. What we found here is we were asking the question, where is the catchment area of the early childhood development centers? And so there is a catchment service area tool in the GIS applications, or in ArcGIS, where I wanted to see, okay, so if I know where all the early childhood development centers are located, I want to be able to map how many households, where are the households that are within a 15-minute walk to the childhood center. And again, this is based on the road network and not the Euclidean distance. So I wanted to see and be able to capture who all food insecure households are within a 15-minute walk to their closest early childhood development center. This provides a catchment area of service. When you map this, you can identify easily service area needs. So pretty much the red dots that you see that are not encapsulated within the purple polygons, these are going to be neighborhoods, or these are going to be individual households who are experiencing food insecurity that do not have easy access to an early childhood development center for emergency food. Another application of spatial analysis is in transportation. Here, I wanted to look at the transport to food, mainly because we recognize that most households, especially low socioeconomic households, do not have access to a private vehicle. So they are dependent on transit or walking distance to get their food at local supermarkets. And we do know in this study that most families do rely on supermarkets for most of their grocery shopping for the household. So we factored in, okay, so what is the walkable distance to a supermarket, considering the carrying capacity, so the capacity to be able to hold your groceries and or take children with you to the supermarket. So we found that to be the most being 1.5 kilometers. So when we identified this catchment area of supermarkets, we wanted to see where potentially could we place a new minibus taxi rank in these areas. And so we mapped the taxi ranks in relation to where these people live. So we do know that people are willing to walk up to 1.5 kilometers to a taxi rank. And with that said, where should we put any future taxi ranks based on where we know that people are willing to, based on what we know about people willing to walk to a taxi. So that is another tool that we can use that serves a transportation function in community development. Other examples is in food systems planning and policy. So, I have this example of the food shed again, because it provides a great example of the food system in an area, and that could be incorporated into future planning and policy. So we can look at farm to table policies, urban agriculture, food hubs, opportunities for community kitchens. This also can provide information for economic development policies, whether it be tax increment financing strategies or sustainable agricultural investments. We can also look at food retail and vendor policies. So here we have an example of bread prices, commercial bread prices. So this is how much commercial bread is in an area, and I use an interpolation of the cost of commercial bread in the city of Worcester. And this tells you the types of retailers that are selling the bread and how much they're selling the bread for. So what this can inform is pricing strategies. So if areas that are just unaffordable, for example, fruits and vegetables, it provides an idea of where we want to prioritize any kind of pricing strategies or economic incentives for retailers for product availability, product placement, and product promotion. So with that, I have some concluding thoughts to share with you. Spatial data adds a dimension to data analysis. It provides the where our resources are, where do we prioritize interventions. We can use descriptive and inferential statistics in spatial analysis, and I demonstrated those examples through cluster analysis, through modeling, and interpolation. As I mentioned before, spatial analysis provides a powerful visual to display data, and there's many implications toward people and place-based interventions and policy strategies. I want to thank you for listening to this presentation, and I'll be happy to answer any questions you may have.